Hi team, welcome to video 3 of this video series on how to fill out Appendix 5, the Financial Sustainability Worksheet. In the previous videos we've gone through how to fill out the initial information on the Financial Summary tab, the operational cost, as well as in this most recent video, in this past video, video number 2, the Capital Cost Worksheet, which is a new worksheet. I'm showing you, we've gone through so far this worksheet and filling out the top half of this, the average inflation rate worksheet, this one as well, and finally the last video was about how to fill out this worksheet. This video that I'm recording for you now is going to cover how this section of the financial sustainability worksheet gets filled out. As you see, it's grayed out, so you can no longer enter values in here. But instead it's going to pull values and pull a lot of information from this new tab called Repair and Replacement Cost. And so in going to this, the reason that it has its own tab is because we want to introduce another level of clarity and guidance into this process. Now in the past, we just simply asked you to declare what the capital cost was as well as what the lifespan was. But the thing is, we realized that that wasn't really an accurate question to ask, because we realized that some things do have a lifespan and have a capital cost associated with it. Think about the pump, for example. The pump estimated between $1,500, $2,000, maybe between $1,000 and $2,000, and has a very definite lifespan, somewhere between 5 and 10 years. But how do you estimate the lifespan of a structure, for example, the concrete structure? When you may expect that thing to last for a very long time. We've been saying in past worksheets that it's been about 30 years. But in reality is once this is initially built, it could stand for almost 100 years, maybe more. Really, it's hard to discern, especially on the longer term lifespan. So it may continue to stand, but even though we won't need to replace the structure, there's still this idea that the structure will require some occasional maintenance. So we will see a crack that will appear in the structure. So then we might ask the operator to go get some materials to go fill in that crack. Something else that might take place is the tap stands might fail. But the tap stands are probably going to fail on a somewhat regular basis and not all at once. So if there's a number, let's say there's 15 tap stands in the community, not all 15 are going to fail within 5 years. You might have some that fail within 2 years, just a couple faulty ones. You might have some that last as much as 10. Again, it's really just kind of hard to figure out what is the lifespan of the overall, all the tap stands within the system. So this introduces this idea of more of like a maintenance cost. You can also think about this like with piping, for example. You're not going to replace all of the piping in the 30th year of the project. You're probably going to replace, if we actually do a good job, probably not going to replace anything for a good number of years. But if it's exposed piping that's visible to the environment, that can get tampered with, and perhaps even experiences rain and perhaps some corrosion over time, yeah, there's probably some cost associated with replacing that. So this is ultimately a concept that is in tension and that we try to implement into this newest version of the Financial Sustainability Worksheet, is this idea that yes, some parts like the pump do eventually break and will need to be repaired. And you're probably also not maintaining or repairing that pump over the course of time. It probably just fails after a certain amount of months or years in use. But then you have some things that just never really break down fully, sort of like I said, the structure. And so in this is the question that we try to implement into the worksheet and provide guidance in each of these sections moving forward. So going back to the financial sustainability worksheet, keeping this tension in mind between what I'm going to call repair. Repair is something that just kind of happens slowly over the course of time. Just think about that concrete structure, has a occasional repair that's part of it, but never fully replaced, and how that's yet different as a replacement cost, which is hardly ever repaired, but is fully replaced. And again, repair cost that is similar to a concrete structure that requires just an occasional repair from time to time. And a replacement cost is something that would be basically pulled out and a new one, a totally new one put in. And again, this is probably the easiest and best example of this in our projects are the pumps. All right, so then now that we understand that there are perhaps two different costs associated and two different ways of thinking about the equipment, we've created this worksheet that provides guidance in whether and where each of these pieces of equipment falls. So like I said, the pump has a particular category in replacement cost. So if I scroll down, this has been organized by pieces of equipment. So here's the example up here, then there's the water source, then there's a structure, electrical, there's the power supply. I was talking about the pump earlier, I'm trying to find this. Here's the pumping equipment. And I said the pump was something that was replaced, but probably not repaired. So in this case, like we've said, here's a section that estimates the pump and its costs associated with repair and replacement. And we put in some notes here that have provided some guidance to you and to figure out which of these categories does the pump fall in. Now, since I've been talking about it for the last couple minutes, you can probably see them. It's most clearly here is the pump would fall under or have a replacement cost associated with it. But you see there's also a note here that there is no repair costs. So in this example, we leave this blank. You don't even have to put a 0 in here. You can just leave it as is. And I would just put in the number of years that we would expect the pump to last, or the number of years that is required until it's replaced. So I'm going to just say that the pumps that we've installed in this community, 8 years. You might remember that this is in the past versions of the financial sustainability worksheet. This has been expressed as a lifespan. And this is essentially the same thing. We're not asking for the capital costs associated with it next to it anymore like we were on this worksheet. We had done this on this worksheet instead. What we're asking for here is just the lifespan to put in as a simple number right here. And this is only if there's a replacement cost. And you can see we've put in some guidance regarding that. Also something to note, the capital cost has showed up here. The capital cost it shows it's grayed out, so it means it's automatically imported. This comes in from this tab. Comes in from, if I go to pump and equipment, you see the pump, 30,000 lempiras, and it shows up in this box as well. We've asked you to specify the model, so I'm going to just say SQFlex pump, and that way it's just a note to provide some feedback to any reviewing engineers or design engineers, or even myself as I'm reviewing these financial sustainability worksheets as to what pump you're referring to when you're filling this out. Since I'm in this section already, why don't I go ahead and continue to do this for the controls. You see it imported 10,000 in from this capital cost worksheet. So you see 10,000. It's imported here. I'm going to say it's a CU200. And again, I'm in the same situation. There's no repair cost. We're just going to assume we're going to replace the whole CU200 at some point. And we've estimated that at 10,000 lempiras whenever that takes place, and we're going to estimate that that's going to last about 6 years. Okay, so that's filling out the pumping equipment section. Now you remember me talking about the concrete structure and how we would look at that. We look at that in a totally different manner than we do the pump. So if I go up to the structures section here, we can see that the two most common structures associated with our projects are enclosures and towers / platforms. Again, you see the costs, 70,000 and 100,000 pulled in from that previous worksheet. But you can see we have different guidance in here. Whereas the pump was replaced, you'll see under this replacement that the guidance here says that there's typically not a replacement cost. You're not going to be replacing the enclosure in its entirety. You're also not going to replace the tower in its entirety. So we're asking you, and probably in this case, to consider leaving it blank. However, if it's perhaps there might be some scenarios where you have put in an enclosure or a tower platform where maybe it's a little bit less robust than the concrete that we traditionally advise. And so you can go ahead and put a value in here, and it will calculate in the bottom. You are allowed to do that. It's just we perhaps advise you not to. And again, this is just to make this worksheet easier and more accurate. So it gives you the freedom to do it, but we also provide guidance as to what a typical project looks like, so to make this worksheet a bit easier to fill out. So if it's not a replacement cost that guides the structure or is associated with the structure, then it's a repair cost. Remember, we talked about how we're just going to replace some cracks every once in a while to repair the structure. So I said if concrete, repair costs depend on the material of the construction. And I said I've been talking this whole time about how it's a concrete structure. And then you can see further, the guidance here is if concrete, then include 2 to 5% of the capital cost. Now here's where you actually have to determine how much repair cost is going to be incurred on a yearly basis. Wow, this is a hard thing to estimate. How do you know how much the operator or the project is going to have to buy, how much material they're going to have to buy over the next year to replace, or should I say repair, the concrete structure? You just kind of maybe don't know that, and it may actually be 0 next year, but then it might be a certain price after that. It might be 2,000, and it might be 200 the next year. I mean, these things go up and down for sure. So this is like trying to provide some sort of guidance as to what that number is, and so that's why we know that's a difficult thing to estimate, so that's why we provide this percentage as a guidance. So if it's concrete, then we would think that it would be about 2 to 5% of this capital cost. That's why we provide this capital cost right here in this box. So we go ahead and we say equal. You can do this a number of different ways. You can do this with a calculator. You can do this right in Excel though. So we can say it's 100,000. I'll just type it out so it's a little bit easier. It's 100,000 times 2%. And it automatically puts in this number, and you can also see this number show up here in CapEx per year as well. Now again, like things, it can be a little tricky to figuring this out, but again, this guidance is supposed to be trying to provide as much clarity as we think we can as regarding what number should go in here. You can also just change this again to 5% if you think if you think 2,000 is a little low. And even you can disagree with us and say, no, 5,000 is not enough. We think that really, in reality, it shouldn't be 5,000. It should be 10,000 per year. Now we invite that criticism or that critique to say that you have some additional insight into the community and you think the number should be higher. We also say if you really think that it's lower, so before this was even 2,000, and you see that 2%, you can disagree and say you think it's even lower, and you can say it's 500, and this would then be 0.5%. So ultimately, like, we're trying to give as much freedom in this document as we can, but also for those who would like the guidance when filling out this worksheet to also have this level of guidance as well. All right, so moving forward, how does one fill out this worksheet, from beginning to end? So now that I've given you an oversight into how to think about this worksheet, the way I would advise working through this, and again, I try to provide an example up here, but the way to look at this is to, as you're scrolling through, try to look wherever these capital costs are showing up. And whenever you see a capital cost like this declared, that then requires you to fill out these couple boxes here. And so as working through this, if I use my own advice and I look for the places where boxes are filled in, I'm going to try to fill this in from the beginning to end, talking through some of the guidance that's been written here. Alright, so first we have the surface water, and I said that we're going to be drawing from a spring in this community. Now my guidance here that I've developed with the engineer says no additional costs beyond the operator's regular maintenance responsibilities are necessary for this. So what this means is we already make provision in the operator's salary as well as even that upkeep cost to say that this is how this is going to be maintained, and it's probably minor things. It's just to clear some debris away from the source. It's to make sure the fence is maintained. It's some minor things. So we actually say there's probably no additional costs in this section. So you can go ahead and leave this one blank. But if you felt like you really wanted to put some sort of cost in here, you can go ahead and put a number in. And we try to provide some guidance on what that number should be. So in this regard, it was a an estimate for my engineering team and what this number is, and this will automatically update depending on whatever the currency is, as well as country that you're working in. So again, if I was to go back here and to say pretend we're in Uganda, and 3,600 is the exchange, you can see this automatically changes here. So going back to the Honduran example though, we're back to 480. I'm going to say in this case that the local operator has it, and there's no reason to include additional cost here. So even though we pulled in this capital cost, I'm going to go ahead and leave this blank because I don't think that we need to ask the community to go ahead and put any additional provision in the bank account for this section. So then further, we already worked through the structures. You can see, though, I didn't fill out the tower platform. This is also a concrete structure. I'm going to say that this is an old structure though in the system, and that we didn't install this, and it's got some age in it. So I'm going to say it's on the upper end of 2 to 5%. Remember, repair costs depend on the material construction, and if concrete, then include 2 to 5% of capital cost. So I'm going to say equals capital cost times 5%. And there's my number. I'm also going to increase this to what I had put in before. I'm leaving these blank because I said that there was typically we don't have any replacement costs associated with enclosures and towers and platforms. They're just maintained constantly over the course of time. See the electrical? Let's see, which way should we go with this one? This is, you can say it's not typically replaced, but this is typically estimated about 2% of capital costs. So again, I'm going to do this same thing. So you can see me typing in the actual equation here, but also feel free to hit that equal sign and just type in exactly what you see the capital cost to be. Or you can use a calculator and just input the number directly. So if it was 600, you can say it's 500, you can say it's 600, you can say it's 700. It's really up to you, and all the while this number will change depending on what number you put in. So we said originally it was 600. Solar panels, we said there was 50,000 in this system, and again, just working through this, we see that solar panels are actually a different, an example where they actually have both. So in this case, we advise that there may be both. We say that the operator likely also covers this, but if you felt like you wanted to make some provision for replacement costs, to go ahead and we make a suggestion here. But that's an if, and it's not required. And eventually solar panels will need to be replaced, and we can go ahead and say they don't need to be replaced until about 40 years from now. I'm going to put this back to regular local currency per year. Alright, generator. Interesting one. This is estimated to be about equal or twice the annual fuel cost. This includes provision for spark plugs, filters, and oil changes. So what is the fuel cost? Well, let's go back to the operational cost here. And we said the fuel cost for the generator was going to be approximately, we actually put it into here. The fuel cost is about $30 per month, or 719 lempiras per month. So this is what the engineering team here in Charleston is estimating. So we said it'd be about twice the annual fuel cost. So it's $719 per month times 12 times 2. That's what the estimate is for the fuel cost. And then we also said it would need to be replaced about every 10 years or so. And then finally, as we continue working through here, you can see the water storage tanks, some similar advice here. I'm going to say this is a concrete structure again. Actually, no, in this case I'm going to say it's a plastic structure. It's a plastic tank. And I said if plastic, then there's likely no maintenance. So then this remains 0. You can even put in 0 if you want, but it just goes away. And I said plastic 10 to 20 years, I'll just say 15 just to take an average. And piping, newly installed or in good condition, then 2 to 5% of capital costs. If poorly constructed and or exposed, 5 to 10% of capital costs. And not typically replaced. So again, I'm going to leave this blank, and I'm going to go ahead and say 0.02 times that capital cost, 75,000. I say we did a good job on the installation. And say it's in great condition. So we have the tap stands, kind of the same deal. Again, no years until replacement. Water treatment. We said that we're going to use an LWTS. Different parts will be maintained, replaced over time. We recommend an average of 6,000 per year. I have to admit, I'll get back to that in 1 second. So I'm going to continue filling this out. So there was additional water treatment here, equipment for iron removal. We estimate at 72,000. These are blank because this is other equipment. We don't quite know what goes in here. I'm just going to say that this is also equipment that's just going to be repaired over time. And I'm going to say it's going to be about 5% over time. Okay. So then the next step, now that we fully fill this out, I just want to make sure, anywhere I see a number, do I input a number into one of these white boxes? Looks like I've got a white number there. I've got a number here and here. Looks like I got a number here for the water storage. Same for the pump. Same for the generator. We put something in both categories. Solar panels, the same. Looks like we're in good shape. Alright, so the next thing to check is to scroll. All these numbers are in these white boxes ultimately get summarized down in the bottom of this worksheet. And here it says this is the repair cost, and this is in percent CapEx per year. So it takes that that number that you say is going to be required to maintain or repair the system over time, and tries to estimate that against whatever the capital cost is that's declared on the previous worksheet. And then there's the replacement cost as well. Now you'll see that an interesting point of note is the power supply here. It looks significantly looks like an issue here. All of these are pretty low numbers, but why is there 54%? So if I go back up here and take a look at that and figure out why that may be, you'd see that I made a mistake here in thinking that the 719 times 12. So if I go back up to this section, I'm going to edit this and say it's 54% is probably a bit high. It's estimated to be about equal to or twice the annual fuel costs. So I'm going to reduce this times 2 because I think that 5,000 was a bit high, and even 8,000 is a bit high here. It says it at 27. I'm going to say, just kind of in my intuition, that 6,000 is probably appropriate to continue to maintain the generator. And then ultimately, yeah, we are going to have to replace the generator as well, and they think that it's going to have a lifespan of 10 years. All right, so if I go back to this this table, yeah, again to make sure the numbers make sense, and then ultimately here as well, just make sure that these match up, and these are averages for the overall section. So for power supply it says 25 years, and that's because it's taking some form of an average of 40 years of solar panels and 10 years for the generator. Okay, it's just reporting out what, in some sort of format, what you are putting into those white boxes. Okay, So now that they've done that, you can start to see some of these other tables here, which are estimating and automatically calculating what the costs are for each of the costs are for, after filling in all those fields. So you can see that after filling in all this information, you see that it's estimating a monthly target already, and it's estimating in both the local currency as well as in US dollars. And that's also reflected here on this worksheet as well. It's not loading. Give me one sec. I have a little bit of a glitch here in the worksheet. There we go. Starting to see that show up as well. And it's also integrating ongoing follow-up costs, so they don't quite match because it's. But you can see if I highlight all of these, you see $120 here, as well as $120 here as well in total. Okay, so in the next section, I'm going to go through next video. I'm going to go through a couple other factors, and that's this category as well as the inflation, and how this should be factored in, thought about when filling out this financial sustainability worksheet as well. So I hope that this worksheet was helpful. This is certainly the most complex, but I hope that over the course of time, as you get used to filling out this worksheet, that it will become a lot easier. You will get familiar with it. You will know how to input the values that make sense for your context and the communities in which you work. Please, I expect you to be reaching out to me with any of your questions and your concerns as you're filling this out, and I'll be happy to be, and I want to be highly responsive to your needs and making sure that this tool remains to be something that is easy for you to use, is accurate, and also provides targets that are attainable for our communities. So with that, thank you all for your patience, thank you all for your participation on this, and look forward to working more with you in the future.